Hey everyone, this is Unit 4, and we are doing topic 3. And we're solving systems of equations using elimination in this topic. So this topic is slightly different because our step 0, the first step that we're doing here, in substitution, we were looking for variables to be isolated. If we use elimination, we are looking to see that our equations line up when they are stacked. And line up, it means the x's are lined up, the y's are lined up, the equal signs, and then the numbers lined up when they're stacked. And that's true in this case. So I'm going to move on to the first step. The first step says to add up the equations to eliminate one of the variables. So the way that this first example works is I'm just going to show you. I'm going to just put a line underneath here and add up these equations. And if I add up the x's, I get x plus x is 2x. If I add up the y's, I get 2y minus 2y. That actually adds up to 0, so I can cross those out. I bring down my equal sign, and then I add up the 8 and the 4, and I get 12. And what I'm left with, if you read step 2, it says your new equation has only one variable. Look at my new equation, 2x equals 12. I can solve that equation by dividing by 2. And I get x equals 6. Let's go to step 3. It says take your solution from step 2 and plug it into either equation. So I'm going to pick an equation. I'm going to rewrite my first equation, x plus 2y equals 8. And I'm going to plug x in. So I get 6 plus 2y equals 8. And I can solve this equation by subtracting 6. I get 2y equals 8 minus 6 is 2. Divide by 2, and I get y equals 1. And so there is my solution. I have an x and a y, so I know that I'm done. All right, so on to example 2. And the big thing about example 2 is, well, step 1 is already done. Step 0, sorry. Our equations are lined up. We have x, y, equal sign, number. Step 1 isn't just to add up the equations, because if we just added up the equations right now, nothing would just cancel out. Look, 4x minus x is 3x, negative 2y and 3, none of these cancel. So what we're going to do is we're going to multiply using distribution one of the equations by a number of your choosing to make one of the variables eliminate. So you can kind of have a choice here of what variable you want to eliminate. I'm going to eliminate the x's, and I'll tell you why. I'm going to eliminate the x's because this bottom equation, I'm going to put it in parentheses, and I'm going to multiply it by 4. And if I distribute, I'll get negative 4x plus 12y, and then I also have to distribute over here, equals 8. I've multiplied that entire equation by 4. Now I'm going to take this equation right here, my original, and just rewrite it down below. And that is 4x minus 2y equals 12. And the reason I multiplied by 4 is because when I add these equations, look what happens. Negative 4x plus 4x is 0. They cancel out. And then I'm going to add these numbers, positive 12 minus 2, and that gives me 10y positive equals 8 plus 12 is 20. Really simple equation. It only has one variable. Divide by 10, and I get y equals 2. All right, next I want to figure out what x is. I pick either equation. I'm going to pick the second equation, this one, because it looks a little bit easier. I'm going to rewrite it. Negative x plus 3y equals 2. Negative x plus 3 times, I know that y is 2, equals 2. So that's negative x plus 6 equals 2. subtract 6, and I get negative 6 equals 2 minus 6 is negative 4. And that means that x is actually positive 4 if you divide both sides by negative 1. All right, moving on to this example 3. Step 0, make sure your equations line up. That is true, we have it. In this equation, in this example, we're going to have to multiply both of the equations by a number of our choosing to make one of the variables eliminate. And the reason is because if I try to eliminate the x's, there's no number that I can multiply by 2 that will turn it into the number 3. That's an easy number to work with. And I can't multiply 7 by anything to turn it into negative 4. So I'm just going to pick one of these, and I'm going to actually pick the y's because one is positive and one is negative, and that's going to do a little bit of the work for me. So I'm going to multiply this top equation and this bottom equation both by a number. I'm going to multiply the top equation by 4, the bottom equation by 7. I'm going to rewrite my equations here. So I get 4 times 2x, that's 8x. 4 times 7y, that's 28y. And 4 times 16, that's positive 64. I'm going to do the same thing on the bottom. 7 times 3x, that's 21x. 7 times negative 4, that's negative 28y. 7 times negative 5, that's negative 35. Now I have two equations, I'm going to add them. And look what happened. Negative 28y plus 28y cancels out. So I get 8 plus 21x, that's 29x. These cancel. 64 minus 35 is positive 29. Divide by 29, I get x equals 1. To find y, I pick either equation. I'm going to pick the top equation. I'm going to plug x in. 2 times x is 1 plus 7y equals 16. That's 2. That's 2 plus 7y equals 16. Subtract 2, and I get 7y equals 14. And I know that that is y equals 2 if you divide both sides by 7. Alright, on to example 4. So example 4, we don't have the steps written out, so we kind of have to make a decision here. And I'm going to look and see first if any of my variables will eliminate right off the bat. And I see that the y's look exactly the same, except for one is positive and one is negative. So I'm just going to add these equations. And I get 2x plus 3x, that's 5x. My y's cancel, equals 15 plus negative 5 is 10. Solve this equation by dividing by 5, and we get x equals 2. Now I pick either equation, I plug my x in. I'm going to pick the top equation. 2 times my x is 2 plus y equals 15. So I get 4 plus y equals 15. Subtract 4, and I get y equals 11. Alright, let's look at the next one. So the next one, now if I went ahead and just added these, nothing would cancel. The x's are very close, but they wouldn't exactly cancel because 3x and 3x gives you 6x. And actually, I would say the easiest way to get these is to cancel would be to pick one of them. It doesn't matter which one. I'm going to pick the bottom one and multiply it by negative 1. And the reason I'm going to do that is because if I multiply this by negative 1, I'm going to write my new equation right here. If I multiply this by negative 1, I get negative 1 times negative 2y, that's positive 2y. Negative 1 times 3x is negative 3x. Negative 1 times negative 4 is positive 4. I'm going to take this top equation and rewrite it. 5y plus 3x equals 10. Now we're just going to add these equations. 5y plus 2y is 7y. Since I multiplied that equation by negative 1, my x's now cancel, and I get equals 14. divide by 7, and I get y equals 2. To get x, I just plug this in. I'm going to pick the top equation. 5 times my y is 2 plus 3x equals 10. 5 times 2, that's 10, plus 3x equals 10, minus 10, and I get 3x equals 10 minus 10 is 0. 3 times what number is 0? If I divide by 3, I just get x is 0. Alright, example 6, and there's a little star next to this because this is a special problem. It's a special case. So I notice right away that actually the x's, look, they're all set up. They're going to cancel if we add them because they have the same number out front but a different sign. One's positive, one's negative. So I'm going to add these. I get negative 2x plus 2x, that's 0. Okay, those cancel. I also get 3x plus negative 3x, that's also 0, those cancel. Then over here I get 10 plus negative 10, that's also 0. So I'm not going to leave my paper blank. I can actually put, okay, everything on the left canceled. The left of my equal sign, I really got 0 on the left. Everything on the right canceled, I got 0. This is a true equation. My variables canceled and this equation is true. It is always true. That means since my variables canceled out, that I don't just have one solution. There are infinite solutions to this equation. Alright, let's look at the next special case, another special case here. And in this special case, I think I need to multiply because right now nothing will cancel. So I'm going to take this bottom equation and multiply it by 2. I'm going to rewrite my new equation here. 2 times x is 2x. 2 times negative 2x. Oh, I think this should be... I think I have a typo here, guys. This should be a y. Sorry, that should be a y. And that should be a y. My bad. Can you make that correction, please? So 2 times negative 2y would be negative 4y equals 2 times 3, and that would be 6. Alright, and then up here we have negative 2x plus 4y equals 5. Alright, so now I'm going to add these equations. Negative 2x plus 2x, that's 0, it cancels. Positive 4y plus negative 4y, that's 0, it cancels. 5 plus 6, that's 11. So I bring down my equal sign. I'm not going to leave this blank, I'm going to put 0 because everything canceled. I get 0 equals 11, which is not true. That is false. And if all the variables cancel and you're left with something false, that means there is no solution to this system of equation. Remember, no solution really means that our lines are parallel if you were to graph them. They're parallel lines. They have no intersection point. All right, you guys are on, I believe right now, homework number 4 in the Unit 4 packet. Good luck.